I've been sprucing up the studio the last couple of weeks. I say studio, it's just a basement, but this place, I've been sprucing it up by moving lights off of stands and onto a lighting gantry that I built out of black iron pipe. I was going to do a video about that. It's not really germane, I don't think. But in part of this is also getting the cameras off the ground. So for example, I have this studio camera on a fairly robust tripod, and rather than have it sitting on the ground taking up space, hang it from the ceiling. Although actually I'll be using a micro studio camera for that purpose, because obviously, well, actually here's the micro studio camera I'll be using, and obviously with a very small camera body and a small lens on it, it's going to be easy to attach to an armature and sort of have it hanging from the ceiling and move it around as I need. In fact, I already have one hanging from the ceiling right there. Well, not the best lighting over here, but this is the idea. It's on this armature that can be locked into place, so I can put the camera anywhere, well, within reason, aim it all around, and it should be pretty handy having it on the ceiling and not on a tripod, taking up valuable floor space. But as you can see, this one is not rigged. There's no wiring coming off it at all. And that's what this project's about. Well, this project's about sort of three things relating to this. In a previous video, I think a couple of years ago, I discussed the ATEM Studio Converter, which is basically a media converter allowing you to use fiber optics. For example, with this camera that's just out of sight, it's connected via fiber optic cable to the switcher. And these full-size studio cameras, well, the first generation full-size studio cameras have SFP slots so that you can attach a fiber optic line to them natively. Micro studio cameras do not, but Blackmagic does sell a mini converter optical fiber 12G, which you can pair with a micro studio camera to make the micro studio camera optical, in essence. I mean, obviously it's a converter, it's a separate thing, but so the point is, on that armature, I would like that camera to be connected via fiber optic cable. Of course, the thing with fiber optics is you still need to get power to the camera somehow, because, well, you can't power it using light, unfortunately. Both of these devices take 12 volts DC. Actually, according to a post on the Blackmagic forums, the micro studio camera, although it's only specified to take 12 volts DC in, apparently it's good for 12 to 18 volts, which is great for battery systems where you might have closer to 14 volts when the battery is fully charged, and as the battery depletes, you might get down below 12. Maybe it'll shut down. I haven't tried that out yet. Doesn't matter. The point is, I'm going to be providing it with about 14 volts, just because that's what the power supply I got can provide, and this way it'll accommodate any voltage drop on the cable, so maybe by the time it actually reaches the studio camera, it'll be closer to 13 or maybe even 12 point something volts. We'll find out. Both these devices come with, similar to this, like a wall wart style power adapter. We've all seen these before. Hooks into a mains outlet, 12 volt barrel plug on the other end. Problem is, this is all going to be on my rigging above my head, and just the idea of putting tons of these types of adapters up there, I don't know. I don't favor it. There's no good reason not to do that, because I have power going up there already, so I could just connect these style of adapters to that. But it also makes the rigging a little more cumbersome because it's just more cables and more stuff attached to Anyway, it doesn't even have to be fiber optic technically. I'm kind of going overboard here. And so what we're going to do in this video, or what I'm going to do, and you're going to join me in the process, I suppose, is using some or all of this stuff here. I'm going to create a couple of boxes that will take XLR 4-pin input, which will just be 12 volts, and have multiple, I'm going to go with 3 locking barrel plugs. So this way I can have nice 12 volt shielded cable running overhead in the gantry system. I say gantry system, it's just a bunch of metal pipes, but you get the gist. Not have it susceptible to any interference, or at least minimal interference, because it'll be shielded. Have it go to this box then splits it out to however many DC barrel jacks I need. The reason I'm going with 3 is because I have the optical fiber converter, the camera itself, and also I might want to have a monitor on there, so hence 3. The thing is, and I'm just using this power adapter as an example because I haven't opened these packages yet, but the power adapters in these packages are rated for these devices. So one of those is not going to be able to provide sufficient amperage to run those two devices, then plus a monitor. So I can't just use one of these and split it off. I mean, I guess I could if I just got a higher amperage model. Point is, I want to do this fancy. And not only is this box going to be a power splitter, I'm also going to throw a volt and amp meter on it just for fun. And to provide that 12 volts DC, I got this Core Cube 200. It's a 200 watt DC power supply, which has two 4-pin XLR connectors on it. So that's two things this video is going to be about, is getting power to the camera and also trying out the optical fiber converter, which I haven't used before. I mean, let's slow down. I have used it before. I just got another one of these, and it's actually attached to the camera you're looking through right now. But I haven't really played around with it. I just hooked it up, and it's the first time I've used it. So this will be, I guess, technically the second time using it, but I mean, this whole process is the first time I've ever used these. And even though this is a 12G converter, I'm just going to be using 6G SDI standards because I'm shooting at 2160p, 24 frames per second, so it's not really germane. The third thing is, well, in assembling all this stuff, I'm going to be soldering, and this is a complete tangent, and I'll probably move this to the end of the video. 5 years ago, I got this Pace soldering station. It's by no means a cheap soldering station, but it's one of the cheapest that Pace makes. But I was really interested in their cartridges more so than the station itself, so this has no fancy bells and whistles, but it does use quality Pace cartridges. The reason I bring this up is because when I got this 5 years ago, I just planned to use it, no problem at all. When I opened it, I saw a bit of a weird thing. Well, let me just show you. Got the rest of the accessories out of here for the moment. This is still manufacturer sealed. I haven't even taken this out of its bag yet, although I did unbox it and look at it through the bag, which is obviously clear. And here is what caught my eye. It's that piece of metal right there that you can see through that grate. That little silver round thing is actually the end of, and after all that waiting, it is just a burr in this little cutout. Great. And there's just a big transformer in there. This is the business end, and that's all there is to this. So, yeah. Okay. Waste of 5 years. Waste of 5 years. Probably won't even leave this in the video because it makes the whole situation and me seem really stupid. Yeah. Okay, let me just close this back up. It really looked like the end of a thick solid core wire. I thought a large inductor or something had come loose because I've had that happen before. Well, anyway, soldering station is fine. Let's just move on with our lives, pretend that didn't happen. Never mind. Okay, so to make this happen, I didn't buy project boxes specifically for this task. I have a whole box of boxes, and I figured I must have one that'll fit and will be suitable for the purpose. That's kind of true. Now, this box is sort of the ideal size. By the way, the mini converter optical fiber does not come with an SFP, so you have to provide one of your own or buy one with it. I happen to have a bunch of those laying around, so that'll be fine for me. So this project box is sort of ideal because it's roughly the same dimension as the mini converter. Obviously a bit thicker, but this way I could Velcro this onto here, well, onto the bottom, I guess, and then strap this next to the camera. But here's the problem with this box. Where do I put the XLR connector? Because it's, so now with the cover removed, well, you can see the problem. The XLR connector does not really fit on there, at least not without straddling the lid. And it's even worse in this orientation, although technically it would work kind of in that orientation. Now the other option is, of course, I could put it on the surface of the box, which does have enough clearance for the wires behind it. That's fine. So I could put it, let's say, here. But, like I said, for fun, I want this little voltmeter ammeter thing. And so if I put the voltmeter ammeter there, but then it becomes a problem of where do I put the barrel jacks, because they, of course, protrude into the case themselves, and I can't really put one where this is, because it wouldn't fit in there. And even with the XLR connector, it would be it'd be too tight a tolerance, too tight a clearance. So I could push the XLR connector towards the edge and not have the back of this be symmetrical. And then we'd be fine on clearance there. And actually fine on clearance there because this is a plastic body. So even if we get some contact, it's not an issue as long as we don't get up here with it. But I don't know, it just looks kind of naff having these off-center. I mean, the other option is having those off-center, then putting the barrel jacks meow. So yeah, I think that's what I'm going to do. I'm just going to put all the components on the lid, barrel jacks included, and so we'll have 3 barrel jacks and then these 2 objects, and then all the cables will come out of one side of the box, which will actually be kind of handy because then the box can be mated to this and we have all our cables coming out here. Although if I am using it for this purpose, it might be better to have a barrel jack here just so I have a short little jumper over to here. And the reason I'm going to put everything on the lid rather than the base is because the lid is more shallow, so it'll be easier to position everything and then solder it after it's in place. The only thing that worries me is this has to rotate, so I gotta make sure I don't put that right up against the edge of the case. That leaves kind of very little room on this side though for barrel jacks. Well, enough waffling, let's do it. It's not like this has to be a hyper high precision endeavor. That's about 2 centimeters in that way, and I'm going to guess 2 centimeters in that way. That's obviously not the diameter of the thing. I'm just going to use a step bit and just check it as it goes through the steps until I get to the diameter I need. And actually I'm going to drill that and then position the XLR connector here so I know I'm clear of that and I can mount this device first just to check my clearances. Well, the box isn't very sturdy. Are we there yet? One more. Actually, that step should probably do the trick. It's just I got to come at it from the other side. Ah, beautiful. And yeah, sorry these cameras aren't well matched, but I am going to be replacing this camera with a Micro Studio Camera G2, which looks more like this. Well, it looks exactly like this. Where did I put the nut? Oh yeah. And then we know where we can place the XLR connector. Now, of course, this has the bezel on the outside of the device. So on the inside, all we have to do is worry about the clearance around this barrel. Just for appearance's sake, I'm going to keep it as in line and centered with this as possible. But again, I'm doing these measurements in a catastrophically crass fashion, so who knows where we'll... And this is also very slippery plastic, so this is going to move around. But we will persevere. I think that step is the one. Although there are like little nubbins here. I may use a file to create indents for those. So let's just, just YOLO this. And so the body of the device goes in like that, but there are these little nubbins or whatever, locator things. Okay, I eyeballed that square to the box. $10 says it comes out squint though because I'm going to get these notches in slightly the wrong place. But hey, what I said about filing it down, let me just try something a little more ghetto. And let's see if that lined up. And there we go. So it is a little squint though. I guess I can widen those holes a bit, although we could just use some caliber of brute force. The wrong tool for the right job. Well, there we go. That's pretty square. A little more. The advantage of working with relatively soft plastic. And let's just make sure the faces of these two don't collide. No. Perfect. And then I will, of course, be screwing this down. And then the main issue is we need the barrel jacks to stay clear of this stuff. So yeah, I don't think I'm going to be able to fit one there. So I think I'm going to either have to position all three like awkwardly close to each other, or maybe I will put one on the bottom of the box coming out. Now, is that going to clear the XLR bezel though? That's the issue. I'm starting to think maybe I'll have all three barrel jacks coming out the sides. And as long as I drill in those locations, these jacks should be fairly symmetrical, although I'm sure I'll screw it up. On this very slick plastic, it's hard not to get it to wander a little bit. So I think that middle hole is a little high, but not the worst thing in the world. Oh yeah, that's actually perfect because the threads just are sort of catching a little bit, but it will seat all the way in. Obviously this is the wrong way around, but you get the idea. Do we have enough clearance off that post? If I don't, I'll just clip the post off. Yeah, the post is in the way. I mean, this could be dremeled off. You know, you could use any other number of means for removing this, but I don't know. I find side cutters work pretty well, even if you do have to like mince it up a little bit. And I'm going to have to get it out all the way, just get it down enough that the body of the connector can pass over it. And this one has a little bit of a clearance issue with this post, but just a touch. Actually, I guess both ends do. But that's okay. We'll just ream that out a little more on that side. All right, well, anyway, let me get all this crap out of the way and start wiring this thing up. So I guess the first thing I'll do is wire these up and then put them in here, because it's going to be much easier to solder them before sticking them in there. And I also got the mating connectors so that I can make up short jumper cables to go to the devices. And obviously they're all locking type. Although, bollocks. Is that a different thread? These barrel plugs are super long. So the barrel plug is bottoming out before the threads can catch on here. Now, that's what I get for buying this off Amazon, I suppose. Well, alright, fortunately these are just going to be used in a fixed studio environment, so I don't really have to worry about these falling out randomly. That's moderately annoying though, because I went to the trouble of buying these specifically for that purpose. But at least they'll be able to lock into these. So that's cool. Oh, and for this entire thing, I'm going to be using 14 gauge wire just for the extra ampacity, even though this is going to be fed by 16 gauge or even doubled up 18 gauge wire. But, you know, the thicker the better. And for the ground, let me just try something. I'm going to strip this extra long on the end here, and then we'll come in like maybe there-ish. I mean, 14 gauge just is real tricky to solder to these. I'm just going to get a little experimental here, so just bear with me. So I'm just going to take a few strands, twist those up nice and tight, and pass it through here. Now it's the sleeve terminal. Yes, it is the sleeve terminal. Splay out these strands, pass this wire through the eye of that, pull that shut, and then bring the insulation, leave a little bit of a gap there because we want someplace for the solder to go, and then bring this around the back of the connector and then twist the end of that loop, and then I want to bring it around there. So now I'm going to trim this off, this tail, after I solder it. But now we've got that connected there, and I'm going to widen this out a little bit, and this will come around the back of this connector, so we'll get a big blob of solder on there. You see what I'm thinking? And then we don't need any heat shrink tubing because the insulation from the wire is about as close as it can get. And then we just trim off this pigtail. And yeah, we have a big blob of solder on the back end of the connector, but not near the pin. So I'll do the positive a little differently than the negative. But I don't know, I kind of like this. It's kind of cool. Well, it's not pretty, but it'll be functional. My first time trying this sort of assembly method, and you can see I got a little chunky here on the end because this 14 gauge wire is a little too thick for these connectors, and I wanted to get a good mechanical connection by getting some strands through the slot and then wrapping it around. And also I got some solder on this one, but whatever, it's fine. Electrically it's fine. And then for the positive connections, I'm going to do those a little bit differently. I'm going to take a little pigtail off of each of these jacks and then splice them together into one wire. Yeah, there we go. And then I decided I'm going to use Wago connectors. Actually, these are knockoff Wago connectors to connect these 3 wires, and then also terminate this black wire into a Wago connector. So this way, if I want to separate the top and the bottom of the box completely, I could easily disconnect them that way. And these being knockoff Wago connectors, I wouldn't use these for line voltage applications, but I don't know. I'm thinking they'll be okay for this. Alright, so that new way of doing things didn't turn out super well. So we're just going to go with the more standard way of wiring these up. Screw it. Well, I'll be screwing them on later, but, you know, screw it for now. Alright. And then I was going to use Wago connectors to mate these up, which is what I started to do in the first place. But the box really is too shallow for these Wago connectors to be in there, so I'm just going to have to splice these together the old-fashioned way. Alright, and there we go. And then as for the way this is going to fit together, I'm thinking the XLR connector should go there, because there's plenty of clearance like that. Well, unfortunately, I thought I had a set like this with fluted head screws, but I don't. So just temporarily, these are kind of the wrong screws, but they should work. I mean, they'll work. They just won't look great. So there we go. These two things are now mounted. Okay, and then this is positive, negative, and in the middle is the load. And I'm definitely not going to have the clearance behind this to make use of these spade connectors as spade connectors, so I'm just going to solder right to them. Ooh, those holes are tiny, though. Oh, you know what I probably should have checked? Yeah. Probably should have done this earlier, but... Okay, good. Good, good, good. We have continuity all through there, and then... Yeah, okay. Cool. I got most of the conductors going into the little end barrel of the XLR connector, and the ones that didn't, I just folded around the side, blobbed it all with solder. That should have a nice, strong, high amperage connection. And then we can tuck this wire out of the way down there. Okay, well, maybe not the prettiest looking as usual, but should be functional. Now, just double check. I just want to double check my clearances so the XLR connector isn't shorting out. No, it's definitely, it's got plenty of clearance there. It's not actually close to any exposed metal. So, yeah, I mean, in theory, this should be good. All right, there we go. A couple of diagonally opposed screws just for now. And then I just want to use one of these for ease of testing one of these. So I just want to make sure we have continuity in all the right places and we don't have any shorts. So first of all, check that to ground. That's good. No shorts there. Pin 1 to pin 4, no shorts. Then pin 1 to ground, we should have continuity. Yep. But not to the middle pin, and then to the middle pin to pin 4. Good. Yeah, okay. That seems to be correct. Alright, so I'll be creating some of my own XLR cables, but this is just for testing, just straight through 4-pin XLR. And let me just take a look quickly at this core CRE. I said core before, it's CRE. It's lighter weight than I expected. But yeah, nice and compact metal chassis. Looks good. 2 separate 14.3 volt outputs. Fuse on the IEC connector in the back. Recessed power strip so you can't turn it on and off by accident. Not power strip, power switch. Recessed power switch so you can't turn it on and off by accident. Yeah, looks nice. 200 watts across both ports. I don't know if they're probably just in parallel, right? Yep, they're just in parallel. They're not separate channels. Turn the unit on. It's weird. It doesn't have any indicator LEDs or anything, which I guess is fine. I mean, can't really complain about that, but you know what? Let's just make sure it's actually putting out its promised 14 volts. Pin 1 should be ground. Pin 4 should be positive. Okay. These probes are just not getting far enough in. Let's check it here. What? Power switch is on, right? Yeah, power switch is on. Just for the sake of argument, what if I plug it into my device? Oh, yeah, I think my probes just weren't getting deep enough. Okay, this is measuring 15.9 volts. I kind of do want to check if that's true. Let's check it on the output barrel plug here. 16 volts. Huh. That's a bit higher than I expected. Is it because it's not under load? You'd think it would be a regulated power supply. It's got to be a switch mode power supply. It's too light to have a transformer or be some kind of linear regulator, so it should output its specified 14.3 volts even under no load. Oh, it just shut off. Why did it shut off? Oh. Wait, is that my cable or... No. What the shit? That's in all the way. Huh. This cable is good. I was using this cable for a long time to power the camera in the front there. It's not my box. If I hold this in the air... What the hell? Maybe that's why I couldn't get a voltage reading on it, because it wasn't on. 16 volts. Yeah, my probes aren't getting loose. This thing's faulty. I don't think it's my power cable. Let me steal the power cable. I mean, I've used that power cable a ton before. I'm going to steal the power cable off the soldering station. That was quite reliable. Yeah, I mean, that's not my probes. That's... Oh, 16 volts. Not 16 volts. So, yeah. Okay. This thing has a fault. that is not what I expected to happen right now. Well, anyway, the point being, it looks like the box is working, but the power supply is not. So, yeah, I guess that's enough of this project for now. So yeah, we have 3 DC barrel plugs for output, which did come out a bit squint, the spacing wise, but it's fine. I mean, three plugs will fit next to each other. It's not like they'll be too bulky. And yeah, apparently the voltage monitoring is pretty accurate. I mean, it said 15.9 and this said 16. I believe this meter, of course, but you know, 0.1 volts, not bad for this cheap ass meter. And yeah, adapter box, hooray! I guess I mean I got this from B&H, brand new, so that's a little disappointing. I guess I'll just return it. Maybe I'll try another one from this company. Now I'm kind of sketched about this company, made in the USA by Core SWX. So it did say Core. Their logo is unclear. Oh, I see what happened. I read it right the first time. It looked like it said, the second time I read it, it looked like it said CRE. But it actually, that's an O that's split in half. And then it says C, but the C is split into segments. Yeah. Not the best logo. But that's just one man's opinion. I mean, not the best hardware either. So, you know, I don't feel bad shitting on their logo when their hardware doesn't work. Of course, it begs the question, do I return this, or do I open it up, void the warranty, and mess around with it to see why it doesn't work? No, I'll probably just return it, because it wasn't horribly expensive, but it wasn't horribly cheap either. So yeah, I think I'll return this. Maybe exchange it for another one. Make sure it doesn't have the same fault and it's not just me. But anyway, thanks for watching. This box was a success. Of course, since I didn't plan it out in advance and just sort of ran with it and didn't have quite the right size project box for what I wanted to cram into it. But it came out fine. I mean, this will work. So, just, you know, I know my wiring job in there might give nightmares to some people. But hey, that's what we do here on this channel. And by we, I mean me. And on this channel, I mean sometimes. I don't know. Anyway, thanks for watching. I've been Scott, obviously, because why else would I have called the channel Scott ... Terrible at outros, so I'm just going to leave.